Okay, so today we're looking at 3.3. It's Notes for Homework 69, using input-output tables to graph a rule or a function. So in this case, in problem number 1, I'm going to write it bigger. The function is f of x equals 3x. It's kind of written small there. And so remember, the rule is 3 times the input. So that's the rule, and that means 3 times the input. And they want you to input the numbers -2. So when you input the number -2, so these are your inputs that they want you to put in. So you're going to show your work here. So it's 3 times whatever the input is. So 3 times -2 is -6. So you get -6 out. And then what happens when you put 0 in? So it'd be 3 times the input. And so 3 times 0 is 0. So you get 0 out. What happens when you plug -3 into the machine? The machine says to do 3 times whatever the input is. So remember, we're just replacing the x. And remember, that's the input. So we're just replacing that with whatever they tell us to put in place of it. So we replace it with -3, and then 3 times -3 is -9. So we get -9 out of the machine. And let's see, did I miss one? And then if you plug in -1, so it's 3 times the input. We're putting -1 into the machine. Positive 3 times -1 is -3 out of the machine. And they say, what if you put a positive 3 into the machine? So 3 times the input. The input this time is 3, and then 3 times 3, 9 is going to come out of the machine. And then we're going to plot our inputs and outputs. So remember, your inputs is the x, and it's the horizontal, and the outputs are the y, which is your vertical. So -2, -6, so we have to plot the point -2, -6. So -2, -6 would be right there. Now we're going to plot the point 0, 0. That's called the origin. Then we're going to plot -3, -9. So -3 is the input, and then the point goes all the way down to -9. And then -1, -3. So -1 is the input, down to -3 is the output. And then +3, 9. So 3 for the input, and then it goes all the way up to 9 for the output. So there's the point 3, 9. And then we should notice how they all line up in a line, and so we're going to draw a line through them, and that's kind of hard for me to draw a line, put arrows, because the reason why we connect these ones and we didn't connect the ones when we were doing domain and range is because we could continue to put more numbers in the input. We could put 1, and we could put +2, and we could put 1/2, and we could put 1/4, and we can keep putting up as many numbers as we want into the input, and it would keep filling this up. So that's the reason why we connect it. So we'll keep talking about that more. Okay, so let's look at example 2. Let me move this up a little bit so we can see it better. In example 2, the rule is 1/2 times the input plus 4. So I'm going to write the rule a little bit bigger. It's 1/2 times the input plus 4. So remember, that's where the x was. So that's what the input is. And so these are what we're inputting. So if we input a -8 and we do 1/2 times -8 and add 4, what does that equal? So 1/2 times -8 is -4, and -4 plus 4, that would give me 0. And then what happens if we plug in a +4? So that's 1/2 times +4 plus 4. So all I'm doing is just each time I'm just recopying it, inserting the new input, and then doing PEMDAS, order of operations. So 1/2 of 4, half of 4 is 2, and then 2 plus 4 is 6. So 6 comes out of the machine. And then we're doing -4, so we have to do 1/2 times the input plus 4. So we're going to put -4, and 1/2 times -4 is -2, and -2 plus 4 is +2. So remember, we have to do PEMDAS. You have to do multiplication first before you add. And then what happens when we plug in 0? So we have to do 1/2 times 0 plus 4. So 1/2 times the input is 0 this time. So half of 0 is 0, right? Because 0 times anything is 0. Then plus 4 is 4. Out. And then what happens if you put 6 into the machine? That would be 1/2 times the input plus 4. So 1/2 times 6 is 3, and 3 plus 4 is 7 out. So these are the ordered pairs now that we need to plot. So we need to plot -8, 0. So -8 is the input, and 0 is the output. That'd be right there. Then we need to plot 4 and 6. 4 is the input, and it goes all the way up to +6 is the output. -4, 2. So -4 is the input. +2 is the output. That would go right there. 0, 4. 0 is the input, and it goes up to 4. And then 6, 7. 6 is the input, and it goes up to 7 is the output. So there's your plotting of your input-output coordinates or points. And then you can see that they all line up in a line because this is a linear graph. And again, the reason why we're connecting them is I could have plugged in +1 there. And if I plugged in +1, that would give me an answer about right there. If I plugged in 2 into this, that half of 2, that would be 2 would be right there. So we only plot a few of them so we can see generally where the rest of the solutions or input-output points would be, right? And these are actually, all the points that are on the line are actually called solutions. They're actually called solutions to this equation. Okay, so let's look at another example. Okay, in this example, it's the H machine. So remember, the H is just describing what type of function. So this doesn't mean H times X. It just means H of X. So H is the kind of machine. And the rule is -1 times the input. So remember, our machine is the H machine. And the rule of the machine is -X. So whatever you're putting into the machine and then something coming out in the machine is called the H machine, right? So they want us to plug in these numbers into the machine. So the rule in this problem is just basically negative and then X. So when we put -5 in, that gives me a -5. And isn't a negative times a -5 a +5 out of the machine? If I put a -3 into the machine, then it's going to be -3. And a -3 is a +3. So notice it's a negative times X. So that's why I have that negative right there. And then we put a parentheses where the input, before we put the input in. And that gives us 3 out. And when we put 6 into the machine, that gives us a -6. So that would just be a -6. And when we put -1 into the machine, that's a -1. So that's a +1. And when we put 4 into the machine, doesn't that then say +4? So notice it was a negative and then the input, a negative and then the input. You can also think of this as like a -1 times the input, right? It's another way of looking at that. -1 times the input. And then we need to plot our coordinates. So we have -5 as an input and +5 as an output. So -5 as an input, +5 as an output would be right there. And -3 as an input, +3 as an output. So -3 and +3 would be right there. +6 and -6. So +6 is the input and -6 down. We've got to go down 6 to get the output of -6. This time the input is -1 and it goes up to +1 as the output. And then we have +4 as the input and down to -4 for the output. So, and then if you take a ruler, always put arrows at the end because it is a linear graph, meaning all of the solutions line up in a line. And again, the reason why we connected it is because we could have added more, could have put 0 on our table, we could have put 1, we could have put 1/2, we could have put 2, and if we started adding more and more and more, you would start to see it filling in. You would start to see more and more points as we added more points to our t-table. So we only added a few points just so we could see where, generally speaking, where the solutions are. So we only added a few so we could see where the rest of them would be if we were to keep adding more numbers into our t-table, right? But they didn't ask us to do that, but we certainly could have. And then the last one. Look at the rule on the last one. Notice the rule on the last one, there's no x, it's just -2. So this time the machine is the F machine. And the rule is -2. And notice there's no x. So, and remember, this is just the name of the machine. So this is just called the F machine. And we're putting in x as our input. That's what's going into the machine. And what comes out is our output, or you might call that the y value, or you might call that f of x. So there's lots of different ways to write the output. So what this means, since there's no x, this is called a constant function. So this is known as a constant function, because it doesn't say f of x equals 2 times x, right? It doesn't say 2 times x, it just says 2. So where do we do with the input once it goes into the machine? Well, this just says no matter what you drop into the machine, -2 is going to come out. So if you drop a -4 into the machine, -2 is going to come out. If you drop 0 into the machine, -2 is going to come out. If you drop -3 into the machine, -2 is going to come out. So no matter what you put into the machine, -2 is coming out. No matter what you put into the machine, -2 is coming out. No matter what you put into the machine, -2. No matter what you put in, -2 is coming out. 5 is going into the machine, -2 is coming out. There's no work for this one because it's a constant function. You're not doing anything to the input. The input's just going in, and the machine's just moving around, and then it's going to spit out a -2 every single time. That is called a constant function, because notice there is no x. So if there is not an x, that is always a constant function. So now let's plot them and see what happens. So -4 into the machine goes in, and -2 comes out. So -4 in, -2 out would be about right there. 0 in, -2 out. 0 in, -2 out would be right there. -3 into the machine, -2 out would be right there. -1 into the machine, -2 out, about right there. And 5 into the machine. So 5 is going into the machine, -2 is coming out. It would be right there. And notice we end up getting what we call a horizontal line. So when you have a constant function will always give you a horizontal line. And remember, we could write this as y equals 2, right? This is fancy function notation, and this is xy notation. So there's a couple ways to write this. So function notation, understanding the notation, and just input, output, plotting the coordinates, the input, output points, plotting them, and then drawing the lines. So that's what your homework's like tonight.